guys, so today we're going to be talking about percent composition, and this is kind of a topic that I hope will be kind of intuitive to you guys. It's kind of a subset off of the mole, but looking at how compounds are composed and what they're composed of. So percent composition is the percent by mass of the elements in a compound. So that's why it has to do with the mole, because it's by mass. And so it's the atomic mass of an element divided by the molecular weight of the compound. And keep in mind that it's the total atomic mass of the element involved. So if I have multiple atoms of the element, I need to add all of those together. And then, of course, since it's a percentage, it's going to be multiplied by 100%. The mass percents of all elements in a compound must total 100%, just like with isotopes and percent yield or percent abundance. Sorry. If you have 3 isotopes, all of the isotope percent abundances have to add up to 100%. Same thing here. All the mass percents of all the elements in a compound must add up to 100%. So let's take a look at an example. What is the mass percent of potassium in potassium sulfate? Potassium sulfate having the formula of K2SO4. So what we have to do here is to find the mass percent, I'm going to have 2 potassiums, so 2 times 39.102 grams per mole, divided by, so that is the total amount of potassium, divided by the molecular weight of the actual compound. So 2 times the potassium plus 1 sulfur plus 4 oxygens, all multiplied by 100%. And so what that ends up equaling is 78.204 grams per mole divided by 174.267 grams per mole times 100%. And so the answer is 44.9% potassium. So in, let's say you had 100 grams of potassium sulfate, you'd have 44.9 grams of potassium specifically. And we could then do the same thing to find sulfur and oxygen. So I'd like you guys on like a scratch piece of paper or something to try and find the mass of, or the mass percent of sulfur and of oxygen. So go ahead and pause the video and see if you can figure that out. Alrighty, so I hope you guys have paused the video and tried to calculate that out. But when you do, you should find that the mass percent of sulfur is 18.4% and the mass percent of oxygen is 36.7%. I do want to take a moment here to comment on the fact that the subscripts here are not necessarily indicative of the majority of the mass percents. So just because oxygen has a subscript of 4 doesn't mean it takes up the majority of the mass percent. You have to include and factor in the actual atomic masses of the elements themselves. So it's not as intuitive as you might think. You can't just like look at it and say, oh, well, it's going to be mostly oxygen and then second most potassium and second most sulfur, because that's actually not true. The majority of it is actually potassium, then oxygen, then sulfur. So you have to really be thinking about that. And that has a little more to do with the fact that potassium had the highest molecular weight, or sorry, atomic mass. Now, you can do this a couple ways. You could also use percent composition to find some unknowns. So percent composition can be utilized to determine the amount of different compounds given the amount of others. So for example, I could ask, what's the percent composition of a compound formed when 2.70 grams of aluminum combine with oxygen to form 5.10 grams of aluminum oxide. So here, I'm asking you to figure out the actual percent composition, not necessarily the percent mass, but it's kind of the same thing, or it's kind of the same process. So I know that I form 5.10 grams of aluminum oxide, and I know that 2.70 grams of that aluminum oxide is straight up aluminum, so the rest must be oxygen. So if I take 5.10 and subtract out 2.70, I get 2.40 grams of oxygen. And from this, I can calculate the percentages, and so I could do 2.70 grams divided by 5.10 times 100, and 2.40 grams divided by 5.10 grams times 100, and find out that it's 52.9% aluminum and 47.1% oxygen. And so from that, I could figure out the percent composition of aluminum to oxygen, which you could use then to try and figure out if you perhaps didn't know the if you didn't know the molecular formula, you can maybe use that to figure that out. So there's a lot of things that we can do with mass percent and percent composition. So we're going to be practicing this tomorrow, so I will see you guys then. Have a good night.